Okay, in part 1 of 2D, we looked at this little chart that's going to help us figure out what we do with all these angles and their relationships in circles. So you might want to keep that handy as we go through here. But let's go through a couple examples and see how we can use this. So first of all, we want to identify where the location is, because that will tell me exactly what I need to do with my arcs. So this one is going to be on the circle. It's called inscribed. An inscribed angle is half of its arc. So if this is the inscribed angle, its arc is going to go all the way from here all the way to here. Okay, so that angle is half of the arc. So to go out to the arc, I have to take 116 times 2. And when I do that, let's see, I get 232 degrees for this arc. Now, knowing that, even though that's the one they want us to find, we could easily find from K to J now just by taking 360 minus the 232. They didn't ask us to do that, but it might be helpful as we move forward. I could also find this angle here. These two are going to be linear pairs, so 180 minus the 116 would give me that. This one here, the vertex is in the center, or not the center, the inside of the circle. So that angle, ooh, look here. This angle, X, I need these two arcs, but I don't have those two. So the two arcs that I do have will help me find these two little pieces here. So to find those two pieces, I'm going to add those two together and divide by 2. When I do that, that gives me each of these angles of 24. Remember, these two right next to each other are a linear pair. So 180 minus the 24 is going to give me 156, and that would be my angle X, 156. Okay, next one. This is an angle K that they're asking me to find. It is formed by 2 tangents. So there's 2 ways we could do it. We can, since we know from J to L is 110, I can take 360 minus 110 and get 250. So the rest of the circle is 250. An outside angle is formed by the difference of the 2 arcs divided by 2. So 250 minus the 110 gives me 140, divided by 2 gives me 70 degrees for this angle right here. Okay, so I subtracted to get the other angle, or excuse me, the other arc. I subtracted my arcs and divided by 2. That's how I get an outside angle, subtracting the arcs and dividing by 2. Or you can do the shortcut that we showed you, where this angle and its first arc right here are always going to be supplementary. They're always going to add up to be 180. So 180 minus the 110 is 70 degrees. Woohoo! Remember, it only works for tangents with outside angles. Okay, let's see if that works on this one. LJ is what they want me to find. They want me to find here to here. This angle of 34 is formed by 2 tangents. So the angle and the tangent are supplementary. So 180 minus the 34 that I know is going to give me 146. That's that arc, and I'm done. Isn't that pretty handy? If you don't quite understand that, please ask questions. I'll be glad to explain it to you in person. Outside angle, the 2 arcs, as I move through, if I follow the sides out, there's this one of 29 and this here of 75. So to find this angle X equals the difference divided by 2. So 75 minus the 29 gives me 46. Divided by 2 gives me 23. That angle right there is going to be 23. Probably the most common mistake is students forget to divide by 2. And the last one, if we look at these 2 arcs that go with angle X, I have this arc here, and I've got this big one outside here. Okay, those are the 2 arcs that I need. Probably easiest, you'll avoid negatives if you start with the outermost one. So to find this angle, I'm going to take 140 minus 74 and divide by 2. Okay, when I do that, I get 66 divided by 2, which is 33 degrees. So if you have any questions on those, please let me know. Use your chart, identify where the vertex is, identify the arcs that go with that angle, and then follow the formula on your sheet. If you have Have any questions, please let me know in class. I'll be glad to explain it to you again.